super excited with the new M7A Genoa instances reaching public preview, and we really believe that this is a step function improvement in performance that you can get in the public cloud. We're looking forward to delivering even more capabilities for our customers with these new instances. And when you look across the industry, we're actually really pleased with the response that we're getting on Genoa based on the leadership and also delivering across a broad number of general purpose server workloads. So I also want to say today that Oracle is announcing today also new Genoa standard, HPC, and dense I/O instances that are expected to enter general production starting in July. Now, I'll say overall, Genoa is ramping very nicely, and you'll see a number of other public instances and customers coming online over the coming weeks and months. But what I did say earlier is that data center workloads are becoming increasingly more specialized, requiring optimized computing solutions across CPUs, DPUs, and of course, AI accelerators. And that's what makes AMD special. Our breadth of our data center and AI compute portfolio actually provides a significant advantage because you can use the right compute for the right workload. So now let's talk about cloud-native computing. Cloud-native workloads are actually a very fast-growing set of applications that are really, let's call it, born in the cloud. They're designed to take full advantage of new cloud computing frameworks, and they run as kind of like microservices. So you split up sort of large amounts of code, and you put them into smaller processes, and then they can be scaled independently to enable 24/7 uptime. The optimum design point for these processors are actually different than general purpose computing. They're actually very throughput oriented, and they benefit from the highest density and the best energy efficiency. So all of these factors actually drove the development of Bergamo. Bergamo is actually our first EPYC processor designed specifically for cloud workloads. So let me tell you a little bit about Bergamo. Bergamo leverages all of the platform infrastructure that we already developed for Genoa, and it supports the same next-gen memory and the same I/O capabilities, but it allows us, with this design point, to expand to 128 cores per socket for leadership performance and energy efficiency in the cloud. Now, I'm very happy to show you, Drew, can I have my chip, please? As you guys know, I love my chips. Our chips. I am very happy to show you Bergamo. This is our new cloud-native processor, and what we have here is there's actually a new compute die. So the compute die is different from Genoa, using our chiplet technology. Each of these 8 compute dies has 16 of our Zen 4 cores, and then we use the same 6 nanometer I/O die used by Genoa in the center. Thank you. So let me talk a little bit about how we do this. If you take a look at the core, the Zen 4C core is actually an enhanced version of the Zen 4 core. It's actually a great example of our modular design approach. When we originally designed the Zen 4 core, it was actually optimized for the highest performance per core. Zen 4C is actually optimized for the sweet spot of performance and power. And that actually is what gives us the much better density and energy efficiency. And the way we accomplish this is that we actually start from the exact same RTL design as Zen 4, and that gives us 100% software compatibility. And then we optimize the physical implementation of Zen 4C for power and area, and we also redesigned the L3 cache hierarchy for greater throughput. So if you put all this together, the result is a design that has 35% smaller area and substantially better performance per watt. Now, from a product standpoint, what does this mean? What it means is the only real difference between Genoa and Bergamo is the CCD core chiplet. So we use the same socket, we swap out the Genoa CPU chiplet, and we put in the Bergamo CPU chiplet. And what you have is each of the 8 compute chiplets on Bergamo contains twice the number of cores as was on Genoa. And that's how we get to 128 cores per socket. But importantly, as I said, it's fully software compatible, and it's also fully platform compatible with Genoa. And what that means for customers is they can easily deploy either Bergamo or Genoa depending on their overall compute needs and their overall workloads. And so we really tried to leverage the overall platform investment in AMD. So let me show you some of the performance metrics on Bergamo. If you compare Bergamo to our competition's top of stack, what you'll see is just incredible performance. We're delivering up to 2.6 times more performance across a wide range of cloud-native applications, whether you're talking about web front end, or in-memory analytics, or very heavy transactional workloads. And then if you look beyond that, in terms of looking at sort of the overall density and capability, Bergamo, again, is significantly better than the competition in compute density and energy efficiency. So what we see is more than double the number of containers per server, and 2 times the energy efficiency in Java workloads. Now, as you can tell, we are incredibly excited about Bergamo as well and the benefits it will bring to our cloud customers. So I'm happy to say that Bergamo is shipping in volume now to our hyperscale customers. And as I said earlier, I always like to talk about how customers are using our solutions. So to hear more about how one of the world's largest cloud companies plans to deploy Bergamo, let me welcome Meta's Vice President of Infrastructure, Alexis Bjorlin, to the stage.